Hello friends, welcome back. Welcome to Kavita's classroom. I hope you're getting the concepts easily now. I'm waiting curiously for all your comments and problems if at all I can be of any help to you. Right. So continuing from our previous content, we studied consumer equilibrium in one commodity case in the previous module. Now the thing in hand is two commodities case. Once again, the same request, like, share and subscribe. Now, let's begin. So, when we talk about consumer equilibrium, once again, I told you several times, I've told you for 6 markers, your mool mantra is you must give the definition, then assumptions, then schedule, curve, and your explanation. If this is the content given by you, in any question asked in eco, micro, or macro, anywhere, right? Nobody can deduct marks because this is what the explanation actually is. Economics is, lifeless without schedule and curves. And any picture, any presentation, when is not explained in words, is again lifeless, right? So explanation is a part of it. Assumptions have to be told because without those assumptions, the law would not hold good, right? And define means we have to begin with what we are talking about. So all these make a part and parcel of every law, every theory which is requiring any explanation on your end. So as we talked about one commodity case, exactly the same set of definition and assumptions would go. We'll say that situation where the consumer gets to have maximum satisfaction and he doesn't have any tendency to change his consumption behavior because he's stable. He's satisfied the most. So this is the definition. Here in two commodity case, you may just add on while buying two commodities X and Y, right? Assumptions again remain the same. Those 3-4 assumptions of continuous consumption, standardized unit of measurement, then rationality on the part of consumer, and yes, the constant money worth, the value of money, the marginal utility of money remains constant. So that again becomes the assumption. So these two are exactly the common parts of what we had discussed previously, right? Now, the schedule curve and explanation would be varying, but we are taking some content from that very explanation. In our previous detail, what did we study? We said that person will never buy anything if he does not have that utility for that price. Means if he finds that utility is less and price is more, why would he be paying more price, right? If you think that something is worth rupees 100 and you are given for 500 or 300 or 200 or even 150, would you be buying? You would not be buying. So every person tries to match the utility with respect to the price which he is going to pay. And because price is expressed in rupees, utilities and utils. So what's the best value? How can we equate these? By dividing it with such a thing which like utils into rupees, which makes it equal to rupee. So what is it? Utils by rupee is the unit of MUM. MUM is marginal utility of money. Means the utils received for every rupee spent, right? That's how mathematically I'm trying to tell you that we land on the expression of Px is equal to MUX divided by MUM. And when we do this, we say now this utility is expressed in money terms. How? Because utility gets cancelled with utility and we are left with rupees. That's why we always say MUX by MUM is utility in monetary terms. That is in rupees. Okay. Now, from this very expression, what am I trying to do for two commodities case? I'm just trying to eliminate MUM here by putting PX down. So what do I get? I get MUX by PX is equal to MUM, and this is my first statement. Right. And yes, because it's a two commodity case, so I'm writing exactly the same statement for the commodity Y. Here it is X, so here it becomes Y. So I have these two equations, MUX by PX is equal to MUM and MUY by PY is equal to MUY. And as math says that A is equal to B given to us, A is equal to C if is given to us. So this implies that B is equal to C. Right, A gets eliminated. So we land on a situation of equilibrium like MUX by PX when is equal to MUY by PY. So we MUY by PY, this is Y. So we land on the situation of consumer equilibrium in two commodities case. I hope this is clear to you till this much. Else stop, rewind, revisit and come till this point, right? We are moving ahead. Now, MUX by PX is equal to MUY by PY is equal to MUM as I have derived. And this becomes our condition and this is what and how we would be utilizing for numericals also. Let us see how do we use it in numericals. For numericals, you would be given these four components, MUX, PX, MUY, PY, and they would be asking you whether the person is in equilibrium or not. So, see. MUX is 20, PX is 4. MUY is 25, PY is 5. Is the consumer in a state of equilibrium if MUM is 5? You have put all the values and you just get to have, 5 5s are 25, 4 5s are 20. Exactly. So all the things are good to go for. So yes, he is in a state of equilibrium. Right. Next question. They say, if MUX and PX are given, MUY and PY are given, is he in a state of equilibrium? What would I do? I'll try to just put all the values and I see that 5 5s are 25 and 5 6 are 30. So I see there is no equality. So my answer is consumer is not in equilibrium, right? And you are just able to have your score done. So now my point is, this equation can be extended to 1, 2, or 100 things, and this is called law of equimarginal utility. As we have written, MUX by PX is equal to MUY by PY. You may write it for n number of things, MUZ by PZ. You may write it for MU1 by P1. You may write to MU AA by PAA. So whatever way you write, ultimately this is all equal to MUM. So if you are writing such an expression, this is called as law of equimarginal utility. So you are not required to go for it in details. It's just one marker at all if it is required, equimarginal utility. Right. Now, moving ahead. Here, now, this is the vital thing we have read so far. MUX by PX is equal to MUY by PY is equal to MUM. And this is, we have to check for the schedule and curve to get the equilibrium situation. To make it very simple, what the author has given you, the author has taken PX as well as PY as rupee 1. What does it mean? Here, author doesn't want to complicate the things and hence the prices have been kept at rupee 1. So there would not be any more columns required to be. So a hypothetical example is given that MUX, the marginal utility curve, what have we read so far? What do we know so far after doing this chapter? That wherever it starts from, it has to go down. So if it is beginning from 17, it will go down to 15, 12, 10, 7, 5. It could go down to any value. And I always recommend students to try their own values because it's only the pattern which matters. That's it. And it should be falling. And MUY they have taken out to be 26 beginning from this and just making it fall. Right. So this is randomly they have chosen. Now, to create it less complicated, they have taken just one value which is common, else all other values are unique. In another level of complication, you would be given many values which are same also. So if we go by the formula, MUX is equal to MUY. So MUX is equal to MUY at this, it means when the person, if we just see this table, what do we get? We get to have answer as if he buys 1, 2, 3, 4. 4 units of X and 1, 2, 3, 4, 5, 6 units of Y. So how do we write it in the bundle set? Because we write for X first and Y later. So 4 units of X and 6 units of Y. This is the state of equilibrium and this is the budget set for him, right? So let me explain it again. He here is assumed to have the prices 1 for both of them, right? The answer is 4 units of X and 6 units of Y. Now, let me help you with a layman's expression, okay? You would have now got to know that by this, how much is he spending? He's taking 4 units of X, means spending 4 rupees because each unit of X is costing him 1 rupee each, right? And 6 units of Y means he has spent 6 rupees on Y. So what's the total expenditure done by him is 10 rupees. Rupees 10. Now, be with me with a simplified expression. You all are very rational, right? So, if you are rational, how much would you be spending? See, the very first rupee which you would spend would be on commodity Y because it's giving you the maximum satisfaction. Because now you have just begun with your expenditure and you have 10 rupees with you. So you have spent 1 rupee here. Okay. Now what would you spend on? You would spend the second rupee here because you're getting 23 units of satisfaction. Then you will spend third rupee here because 19 is the UTIS you're going to get. Now, where would you spend? Now, instead of spending on Y, now you would spend on X because it's giving you more satisfaction. That is 17 UTIS. Now, fifth unit would be spent here. Sixth rupee would be spent here. Seventh rupee would be spent here. 8 would be spent here. Ninth and 10th you may write anywhere, not hard and fast rule, but whichever is less, we prefer buying that more. So 9 and 10. And hence you saw that you tried to manage rationally so that you have the maximum satisfaction. Now this is your home task. And do comment back to me. Are you in a position to spend 10 rupees on X and Y other than this pattern and you get to have more satisfaction than this situation? Now, what is the TU? This is also required and this is also asked sometimes in the papers. Like if you are giving this schedule. So what is the TU earned, total utility earned by the person, by the consumer with this expenditure? So you will write TU is whatever. TU is nothing but the sum of all MUs. So MUs are 26 plus 23 plus 17 plus 19 plus 17. I'm writing in the reverse order, plus 16 plus 15 plus 13 plus 12 plus 10 and plus 10, and this is my answer. Whatever you will write these many utils. This is my TU when I spent 10 rupees. And when I did it in a layman's format, I switched from here, here, right? But if I'm using the formula, I straight away get to know wherever MUX is equal to PX, MUX by PX is equal to MUY by PY, that's going to be my answer. So this was my answer, 4 units of X and 6 units of Y without any further details. I can straight away bang on that, right? Okay, now just pay attention. If we are to make the curve, though these days CBSE doesn't require this diagram to be made, but how do we do it? Because we are going for the simultaneous purchase of X as well as Y. So we would be plotting x as well as y on the same graph, right? On left hand side, we are making utility of x, and on right hand side, we are making it for y. So, and on the x-axis, we are taking two scales. See, this is the ordinary pattern, vertical and horizontal axis. But if we are to show y as well on this very diagram, so this becomes the vertical axis and this scale becomes the horizontal axis. Right, you would be able to see that the origin of y is here, 0, 1, 2, 3, and 4. So how do we do? We try to make this way. So this is x, and for y, this is the vertical axis, and we just try to showcase the horizontal axis beginning from this. So wherever we have two downward sloping curves, because MUs always go down by default. So wherever it intersects, we just drop it down on x as well as y axis. So these many units of x and these many units of y is my answer diagrammatically, right? Because this is the point of equilibrium, MUX is equal to PX here. So answer is 4 units of x and 6 units of y as depicted pictorially when is dropped on x-axis. I did talk about the law of equimarginal utility when we extend that relationship for more than two commodities. If we simply write MUX by PX is equal to MUY by PY is equal to MUX by PZ is equal to MUM, that becomes the law of equimarginal utility. So with this, we are done with the explanation of X and Y, two commodities case. The numerical has also been solved, and it's always advised if it is asked in the examination, you better take PX and PY to be unit, 1 rupee, right? And other level of complications would be discussed in the next module, wherein I'll take some examples and some illustrations to tell in that case how to go about. Till then, study hard. Get back to me with your queries. See ya.